It would be a profound discovery to find life on Europa, but it would also be profound if we didn't.
Europa is one of the coldest worlds in our solar system, a bright white moon of Jupiter covered in thick, cracked ice, with temperatures as low as 160 degrees Celsius. For a long time, scientists believed it was just another dead object drifting through space. But recently, the James Webb Space Telescope detected carbon dioxide and mineral salts rising from deep below the surface, suggesting that something is happening underneath the ice. And according to some reports, this also makes the possibility of life there much more real. But how is that even possible in such extreme cold? What kind of life forms could actually survive there? And what is that billion-dollar mission NASA has already sent to explore Europa? Let's dive in. The frozen moon. Europa was discovered in 1610, when Galileo Galilei pointed a small homemade telescope toward Jupiter. Only about 20 times magnification, nothing powerful by today's standards, yet it changed everything humans believed about space at that time. Later, another astronomer, Simon Marius, suggested the name Europa, taken from Greek mythology. Europa was said to be a Phoenician princess, taken by Zeus in the form of a white bull, and that story stayed attached to this distant moon for centuries. But after its discovery, Europa slowly faded into silence. For more than 300 years, it was treated like a simple, frozen object, just another cold dot in space, far from the sun. Nearly 500 million miles away, scientists believed it was completely dead. No activity, no change, just air frozen all the way down. That belief stayed strong until 1979, because that was the year Voyager 1 and Voyager 2 first flew past Jupiter, and what they saw did not match expectations at all. Europa was not a crater-filled rock like most moons. It was smooth, bright, almost like a polished surface. And that created the first real question. Because in planetary science, craters tell history. If a surface has almost no craters, it means something is constantly refreshing it, erasing its past. Europa had almost no impact scars. Instead, the surface was carved with long, dark lines stretching across thousands of kilometers. These cracks were not random. They looked like the ice itself had been pulled apart, again and again, by something powerful beneath. That is where doubt began to grow, because ice that behaves like that is not sitting on solid rock. Then came NASA's Galileo mission in the 1990s, and this is where things stopped being assumptions. Galileo measured Europa moving through Jupiter's massive magnetic field and found something unexpected. Europa was creating its own response field, not a full magnetic field like Earth, but an induced one. That only happens if something conductive exists underneath the surface, and pure ice cannot do that. But salty liquid water can, and that single detail changed everything. The hidden global ocean. After Galileo's data hinted at something beneath the ice, the next question became unavoidable. If there is a hidden layer under Europa, what exactly is it? For years, scientists kept returning to one possibility, a global ocean, but proving it was not simple, because no telescope can see through kilometers of ice. So instead, they had to rely on something invisible, Jupiter's magnetic field. Jupiter is not a quiet planet. Its magnetic field is about 20,000 times stronger than Earth's. As it spins, it drags this field through space, sweeping it across Europa again and again like a massive invisible force passing through the moon. Now here is where things become strange. Pure water does not respond to electricity. It cannot carry current. But salt water behaves completely differently. When minerals like sodium chloride or magnesium sulfate dissolve, they split into charged particles, ions that move freely. So if a salty ocean exists under the ice, Jupiter's magnetic field would not just pass through it. It would push those ions, make them move, create tiny electric currents inside the ocean itself. And those currents would generate a second magnetic field, like an echo responding back. That is exactly what NASA's Galileo spacecraft detected. But what kind of ocean are we talking about? The ice above it is not thin. It is estimated to be between 10 to 30 kilometers thick, a frozen shell acting like a shield against space, radiation, and Jupiter's intense environment. And beneath that shell lies something even more extreme, an ocean around 100 kilometers deep. To put that into perspective, the deepest point on Earth, the Mariana Trench, is just over 11 kilometers down. On Europa, that deepest point would barely scratch the surface of the ocean system, and the scale becomes even harder to imagine. Europa is smaller than Earth's moon. Yet, this hidden ocean is so deep and global that it may contain more than twice the total water of all Earth's oceans combined, not spread across continents, not separated by land. One continuous, planet-wide ocean wrapped around an entire world. But here is the fact that will make you uncomfortable. We have never seen it. Not once. No image, no sample, no direct measurement. Everything is indirect, built from magnetic readings and chemical hints. In other words, we are describing an ocean that has never been touched, only mathematically confirmed. And yet, this hidden ocean raises a deeper question. Under almost 30 kilometers of ice, in a place so far from the sun, how has this water stayed liquid for billions of years? The impossible heat engine. Europa lies about 780 million kilometers from the sun. At that distance, sunlight is roughly 25 times weaker than what Earth receives. So, because of this, the surface of Europa is in extreme cold conditions. Temperatures drop to around minus 140 degrees Celsius, even in the warm regions, and near the poles, they fall below minus 220 degrees, cold enough to freeze gases, cold enough to turn everything into solid rock-like ice. By all logic, Europa should be nothing more than a completely dead, frozen block of ice. But it is not. Europa is trapped in a gravitational system with Jupiter and two other moons, Io and Ganymede. They follow a fixed orbital pattern, almost like a cosmic timing loop. For every one orbit Ganymede makes, Europa completes 2 and Io completes 4. This constant alignment keeps pulling Europa from different sides again and again. And this process is called Laplace resonance, a gravitational locking system that keeps all 3 moons tightly connected in motion. At some points in its orbit, Jupiter's gravity becomes stronger. At other points, it weakens, because Europa's path is slightly stretched. It keeps getting squeezed and then released as it moves around. This ongoing stress creates internal friction and heat inside the moon, a process known as tidal heating. Not occasional heat, we're talking about a permanent internal energy source that has been running for billions of years. And that changes everything, because this heat does more than just warm ice. Deep below the ocean, scientists believe it may be powering hydrothermal vents on the seafloor, places where water is heated to extreme temperatures, up to 300 or even 400 degrees Celsius, and pushed into the freezing ocean above. These are not small features. On Earth, similar systems create entire ecosystems in total darkness. Black smokers, mineral-rich vents, places where life does not depend on sunlight at all. And that brings a deeper connection. On Earth, we once believed life needed sunlight. That belief collapsed when scientists found entire ecosystems thriving in the deepest parts of our oceans, powered only by chemical energy from hydrothermal vents. Some research even suggests that the earliest form of life on Earth may have begun there, in total darkness, near volcanic heat sources under extreme pressure. And here is the unsettling part. Europa may have had this exact environment continuously for 4.5 billion years, a system powerful enough to keep an entire ocean alive under kilometers of ice. But if this engine is real, and if it has been running for so long, then the ocean beneath Europa is not just stable, it may be chemically active in ways we have never seen before. And that is the moment where a very recent and possibly the biggest discovery about Europa comes in. James Webb's discovery. In 2023, everything we knew about Europa suddenly changed. To understand why, we need to look at one of the most powerful observatories ever built, the James Webb Space Telescope. This is not a normal telescope. It sits in deep space, far from Earth, designed to collect extremely faint light and break it into precise chemical patterns. Instead of taking a simple image, it uses a near-infrared spectrograph, splitting light into detailed signatures, almost like reading a chemical barcode from hundreds of millions of kilometers away. So when scientists at NASA used it to study a specific region of Europa called Terra Regio, what they found shocked everyone. Inside this region, solid carbon dioxide, CO2, was heavily concentrated, not spread evenly across Europa, not randomly scattered across old ice plains, only inside this freshly broken terrain. That detail changed how scientists interpreted the surface. Because carbon is not just another element, it is the foundation of all known biology on Earth. Every protein, every cell structure, every strand of DNA depends on carbon-based chemistry. So naturally, the question became unavoidable. Where did it come from? Two explanations were considered. One, it could have arrived from space, carried slowly by meteorites and dust over millions of years. Or two, it could be coming from inside Europa itself. The JWST data strongly pointed toward the second. Because CO2 was not found in ancient stable regions of ice, it appeared only in young broken terrain, where the surface clearly fractured and changed recently in geological terms. That pattern matters. It suggests the carbon dioxide was pushed upward from below, not deposited from above. In simple terms, material from the subsurface ocean may have reached the surface and frozen almost instantly. Alongside this carbon signal, scientists also detected sodium chloride and magnesium compounds, the same kinds of dissolved salts found in Earth's oceans. This combination is not random. It suggests Europa's ocean is not just water. It is a chemically rich mixture, a frozen oceanic system that has been exposed, cracked, and refrozen again at the surface over time. But scientists are careful here. Carbon dioxide does not mean life. It exists on planets with no biology at all. Mars has it. Venus has it. What matters here is not life, but activity, because CO2 should not stay long on Europa's surface. Jupiter's radiation keeps breaking it apart. So if it is still being detected, something must be producing it again and again. That is the real shock. Europa is not completely frozen and still. It looks like material from inside is coming up through cracks in the ice, reaching the surface and freezing there, almost like the moon is slowly leaking its internal chemistry. And if that is true, then the surface is not just ice. It is a thin shell, hiding something far more active underneath. The radiation paradox. If Europa's ocean is hidden beneath ice, then the surface above it is one of the most dangerous places in the solar system, because Europa doesn't move through empty space in a simple way. It sits inside Jupiter's huge magnetic field, an invisible force that stretches millions of kilometers around the planet. This field traps large amounts of charged particles, many coming from volcanic activity on Jupiter's nearby moon, Io. But the story doesn't end there. Jupiter speeds these particles up to very high energy levels. This turns the space around Europa into a constant radiation storm. So every second, high-energy particles hit Europa's icy surface. For a human standing there unprotected, survival would be impossible. The radiation dose is estimated at around 540 rem per day, enough to trigger severe radiation sickness within hours. Cells would start to break apart. Internal organs would begin to fail, and over time, any delicate biological traces sitting exposed on the ice would slowly be erased. At first, this made Europa seem far less promising, but then scientists realized something unexpected. The destruction itself may be helping the ocean below. When these high-energy particles strike frozen water on Europa's surface, they split water molecules apart in a process called radiolysis. Hydrogen escapes into space, but oxygen remains behind. Those oxygen atoms begin forming molecular oxygen and other oxidants like hydrogen peroxide across the icy crust. And this changes everything, because oceans cannot remain chemically active forever without a constant energy balance. Eventually, isolated water systems run out of fuel. Europa may have solved that problem naturally. Over millions of years, parts of the cracked ice shell appear to slowly sink downward beneath the surface, carrying oxygen-rich material with them, almost like a conveyor belt made of ice. That means the chemicals created by Jupiter's radiation above could eventually reach the hidden ocean below. And once there, they may react with minerals rising from deep hydrothermal vents on the seafloor. In simple terms, Europa's deadly surface may actually be feeding the ocean underneath. It is a disturbing contradiction. The surface is a frozen wasteland where almost nothing could survive. Yet without that same violent radiation, the ocean below might slowly lose the chemistry needed to stay active. Death above, possible energy for life below. And once scientists began putting all these pieces together, water, heat, carbon, minerals, oxygen, billions of years of stability, Europa stopped looking like a frozen moon. It started looking like a place where life might actually have a chance. What if Europa is alive? At this point, Europa stops looking like a frozen mystery and starts looking like a serious possibility. Because when scientists study environments that could support life, they usually look for a few basic ingredients: liquid water, a stable energy source, carbon chemistry, essential minerals and salts, and enough time for life to appear and evolve. Europa appears to have all of them, not for a few thousand years, but for roughly 4.5 billion years, almost the same age as Earth itself. That timeline matters because life on Earth did not appear instantly. It took enormous amounts of time for chemistry to slowly organize into something living. Europa may have had that same opportunity, hidden under ice for billions of years. And if life exists there, scientists do not expect giant alien creatures swimming through the dark. The reality is probably much smaller and far stranger. Most astrobiologists believe any European life would likely exist as microscopic organisms, bacteria-like microbes surviving deep below the surface. No sunlight reaches that ocean. At depths possibly reaching 100 kilometers, the darkness would be absolute. So if life survives there, it would not use photosynthesis like plants on Earth. Instead, it would rely on chemosynthesis, drawing energy from chemical reactions near hydrothermal vents on the seafloor. The same kind of process seen in Earth's deepest ocean ecosystems. And the ice above may actually help preserve that environment. Europa's massive ice shell blocks Jupiter's deadly radiation completely, creating a protected ocean hidden underneath. Some planetary models even suggest the lower ice layers may contain trapped pockets of salty liquid, creating small habitable zones inside the ice itself. But scientists are careful not to jump too far ahead. Because habitability does not automatically mean inhabitants. A kitchen can contain every ingredient needed to bake a cake. That does not mean the cake made itself. Europa may have water, energy, carbon, oxygen, minerals, and time. But no one knows if biology ever truly started there. That uncertainty changes how scientists think about Europa completely. It is no longer just another moon to explore. It becomes a possible second example of life in the universe, a place so scientifically important that even human exploration itself becomes extremely risky. Because if living organisms do exist there, contaminating that ocean with Earth bacteria could destroy one of the most important discoveries in human history before we even understand it. And that is exactly why NASA is not rushing blindly toward Europa. Instead, humanity has already launched something designed specifically to investigate these questions from a safe distance. Something now traveling across the solar system at this very moment. The mission that will decide everything. On October 14, 2024, NASA finally launched the mission built specifically for this icy moon, Europa Clipper. Right now, as this video exists, that spacecraft is already traveling through deep space toward Jupiter. Using gravity assists from Mars and Earth, it is slowly building enough speed to reach the Jovian system in 2030. But here is the interesting part. Clipper will never actually orbit Europa because the radiation around the moon is simply too extreme. Staying there permanently would destroy the spacecraft's electronics within months. Instead, it will orbit Jupiter and perform around 50 close flybys, short passes near Europa, where it quickly scans the surface and collects data before moving away again. Each pass is designed like a surgical investigation. The spacecraft carries some of the most advanced scientific instruments ever sent into deep space. Radar systems that can scan through the ice shell, spectrometers that can map salts, carbon compounds, and hidden chemistry across the surface in extreme detail, and most importantly, instruments designed to directly analyze tiny grains of ice and dust floating above Europa. That may sound small, but it changes everything. As tiny micrometeorites constantly hit Europa's surface, they blast microscopic ice and dust particles into space. Clipper will fly as low as 25 kilometers above the moon, passing directly through this cloud of frozen material. And inside those grains could be traces of the hidden ocean itself. The mission's highest priority target is Terra Regio, the same fractured region where James Webb detected carbon dioxide and ocean-linked chemistry. This is the real test. If Clipper detects complex organic chemistry inside those particles, it would dramatically strengthen the case that Europa's ocean is chemically active, possibly even biologically active. But if the data comes back empty, sterile, and chemically simple, then one of the biggest hopes in modern astrobiology could suddenly collapse. So, after centuries of looking at Europa as a distant, frozen moon, humanity is finally about to investigate it directly. And the answer waiting under that ice may completely change how we see life in the universe. So do you think there could really be a living, active environment hidden beneath Europa's frozen shell? Or is it just a silent ocean with no life at all? And if life does exist there, what do you think we might actually find first? Microbes, or something even stranger we are not prepared for? Let us know what you think in the comments below. And if you liked this video, make sure you give it a thumbs up. Also, consider subscribing to the channel if you haven't already, because we'll be uploading more incredible stories like this one in the coming weeks. Until then, see ya.